Okay, in order to work through some of the word problems that we're going to have, we need to know some terminology that goes along with navigation. And I'm pretty confident that none of you are sailors, so you probably aren't very familiar with all of this. In navigation, and not just sailors, but, you know, other types of navigation as well, direction is often referred to as bearing. Okay, you could be traveling on a bearing of whatever. And it's represented often by this little, or this capital Greek letter. Anybody know what this one is? Beta. Yes, ma'am. So beta will be what bearing is labeled as, if it is. And we can measure bearing one of two ways depending on the information that we are given. So bearing is measured clockwise from true north. So there's true north and there's magnetic north. I don't know what the differences are. I don't think it really matters that I know what the differences are, that you know, as long as you know how to do this part. But it's measured clockwise from true north when additional north, south, east, west info is not given. So, for instance, just a bearing of 65 degrees. Okay? So if it's stated like that, then I go from true north. Now, what we've been doing on the unit circle, or what you do when you're doing pure math stuff and you've got angles, this is 0 and we go counterclockwise. That's the way it works mathematically. When you're talking about bearing, we start at true north and go clockwise. So from here, I'd go clockwise 65 degrees, and it would be right about there. Okay. That would be the direction that it would be headed. Okay. We good? All right. Another way that bearing could be measured, bearing is measured either counterclockwise or clockwise when additional north, south, east, west info is given. So if you are given that, you go whichever direction it's telling you to go. So for instance, this says south 65 degrees east. And you'll always start with north-south first. So I would start south. I start down here, and then I swing 65 degrees east. So this would be the direction I'm headed, and that right there would be 65 degrees. Okay. That make sense? All right. What questions do you have? All right, so some other terminology that could come up, we want to make sure that we can keep straight in our head, is the direction the vessel is pointed. So if you're out in the middle of the water and you're on a boat, and whichever direction your boat is pointed and you're trying to go, that is your heading. You are headed in that direction. That's why that phrase makes sense. That's your heading. But you don't always get to go. Like if I'm sitting in the middle of the ocean and I'm pointed directly at that poster right there and I'm headed that direction, chances are pretty good I'm not going to go just straight there, right? Because the current's going to take me or whatever. So the actual direction, affected by wind, current, whatever, is the course. In a perfect world, your heading and your course are exactly the same, but that's not always the case. Okay, make sense? We good? Awesome. All right, so let's look at some of these application questions. And the most important part of this is getting your picture drawn correctly. Because after that, you're going to be able to solve them, no problem. So we have two ships that leave a port at 8 a.m. Ship A sails with a bearing of north 68 degrees east at a speed of 17 miles per hour. Ship B sails with a bearing of south 35 degrees east at a speed of 12 miles per hour. If the ships maintain their paths, how far apart are they at 2 p.m.? Okay, so when you're going to have to draw a bearing or draw something on a specific bearing, you need a little north, south, east, west place to start. So this is my little compass here, so I know what's going on there. I'm going to start here because it says that they leave port, so this is port. Ship A is going to sail at a bearing of north 68 degrees east. So this is ship A, and this right here would be 68 degrees. Okay. Ship B leaves the same place, and it goes south 35 degrees east. We'll swing this way, and this is 35 right here. And this is ship B. And I don't know if it's to scale or not. It's just where I stopped my line segment, and it's fine as long as we label right. And then I'm going to connect those two because I want to know how far apart are they. So that's what I'm looking for. I know that ship A had a speed of 17 miles per hour. That's not my distance. That's my speed. Ship B, a speed of 12 miles per hour. All right, so if I'm going 17 miles per hour, I start at 8 o'clock, and I want to know where I am at 2 p.m. How many hours is that? 6? So 17 miles per hour for 6 hours. What do I do with that information? Multiply. You got a calculator? What's 6 times 17? 102. So this is 102 miles is the distance that ship A went. Ship B is only sailing at 12 miles per hour. 12 miles per hour for 6 hours is how far? 72. 72 miles. So I have 102 miles, 72 miles. I'm looking for this distance. I have angle measures, but none of them are inside the triangle, which is what I need. Do I have enough information to find at least one angle in that triangle? Yes. Okay. A couple of different ways I could do that. What's one way? Good. So I can take 90 minus 68 and get this angle, 90 minus 35 and get this angle, and then add those two together. Would that work? What's another way I could do it? 180. I could add these two together and subtract them from 180. Either way works. They're exactly, you get the exact same answer either way you do it. I believe you get 77. Yeah. Because this is 22 and this is 55. And then, so this whole big angle is 77 degrees. Okay, so now, in order for me to find x, I have to decide if I'm going to use law of sines or law of cosines. Which one do you think would work here? Law of sines? Law of cosines? Any other votes? Okay, so if you're not sure, first of all, the information that I have, that setup is side angle side, right? And if you don't remember which one that goes with, that's fine. We'll talk about how that can help and not help in just a minute. But let's say we want to try to use law of sines. So I can do the sine of 77 over x equals the sine of, I need another angle, and I don't have it, so I don't have the information for law of sines. So remember I said, you can't accidentally use the wrong one because you won't have the information. If you think it's one and it doesn't work, it's most likely the other one. Instead of remembering, if it's side angle side or angle side angle or whatever, just remember the two that go with law of cosines, and if it's not that, it has to be law of sines. Side angle side and side 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 are law of cosines. Everything else is law of sines. Okay, to me, I think that's kind of the easiest to remember. All right, so I'm looking for x. When I write down my law of cosines, what goes on the outside? Because it's got to be something squared. What's going to go on the outside of that? Which side length? When you do your law of cosines. Oops. What'd you say? C? Okay, but I need specifically on this one. X. It's got to be the one you're looking for or the one that's across from the angle you're looking for, right? So what you're looking for, if you have all three sides, then the side that goes on the outside is the one that goes with the angle. But it's what I'm looking for. So this is x squared. That's equal to, then you square the other two and add them together. 72 squared plus 102 squared. Minus 2 times 72 times 102 times the cosine of 77. Then you take the square root, and I would just do the whole thing at once in there. Let's see what we get. So you should get 110.833. Do we agree with that? Yes? Okay. So then when you have an application problem like so, you need to actually, you're going to have like a sentence answer here, and we will say, let's see, how far apart are they? The ships are 110.833 miles apart at 2 p.m. Okay, so in formative, when you answer this, in your work, whether you do it on the screen in there or you do it by taking a picture or whatever, the sentence needs to be on your work. What you're going to type in as your answer is just the number and the units. But you got to add the units. Make sure that there's a space right here between the number and the units, just like what you see when it's typed. Okay? We good? Any questions? All right. Let's check out these figure skaters. Okay, so we have Bruno and Aliona. They're figure skaters. They're starting from the same location. Bruno skates 29 feet at a bearing of south. Oh, look, that's in degrees, minutes, seconds. He's going southwest. Aliona skates 18 feet going southeast. All right, so before I put my little compass on there to think about where I'm starting, I may not want to put it in the same spot I did number one. I've got to think about what's happening here. That Bruno's going southwest, she's going southeast, so it would make more sense for me to have it kind of at the top so my picture will come out right. So they start from the same location. He's going southwest about 55 degrees. This is Bruno. She's going southeast about 16 degrees. Aliona. But I need their, and I want to know how far apart they are, but I need their angles, but not in degrees, minutes, seconds. Okay, so I'm going to come over here, and for Bruno, that's 55 degrees, 9 minutes, so it's going to be 55 plus 9 over 60. So his ends up being 55 point, what, 15? And then Aliona, hers we're going to have 16 plus 51 over 60. That becomes 16 point, I think it's 8.5, but y'all check me. 8.5. All right, so this angle right here is 55.15, and this angle right here is 16.85. And let's see, he skated 29 feet, she skated 18 feet, and I want to know how far apart they are. So I have pieces of angles on the inside. What do I do with those two angle measures I found? Add them together. So I'm going to add these two together, and that's going to give me 72 degrees. And then am I going to use law of sines or law of cosines? Cosines, because it's the exact same setup as the one we just did, right? So you go ahead and finish this one up. Any questions at all? Mm-hmm. that's how you find the, that's how you convert from degrees, minutes, seconds to decimals. That's what we did yesterday. Yes, ma'am. Okay. Like, you have it set up right? And then it's not happening here. Okay, so let me see. Ah, that's your problem. Nope, it's in degrees. It's not your problem. Oh, wait, look. This goes on to 72. 18. Okay. 21 squared plus 18. Oh, you're doing times 18 squared. It's plus. Yes, that's why. Change that to plus. Bam. There you go. Okay. Now I'm glad you asked. That's why I want you to ask questions. Okay, are we good? All right. So, number 3, we have a helicopter. Spots 2. Anything else before we move on? Spots 2 landing pads. The straight line distances from the helicopter pads is 14 miles to landing pad A and 8 miles to landing pad B. So let's talk about straight line distances. Straight line distances means that if I'm in the helicopter and I see a car or something down there and I shoot an arrow at it, it's going straight there, that's that distance. Another distance you can have when you have stuff in the air is the ground distance. So the helicopter's up in the air and then the distance to the car, it could be either a straight line distance or it could be the ground distance down here. So when you're drawing your pictures, you want to make sure you know which distance it is. Make sense? So that's why it's important that it says straight line distance. Okay, and we want to find the angle of depression, so we're going to have to remember some stuff from geometry here. All right, so I'm going to start with where my helicopter is up here. My helicopter's up here in the air. And actually, well, it does say below. I was going to say, it really doesn't say that he's in the air, but I guess it does. So he's here. He's got 14 miles to landing pad A and B. So we'll have A over here, and we'll put B over here. So this is 14. This is 8. My picture's clearly not to scale. It's really fine. They are 20 miles apart. Okay. And I want the angle of depression from the helicopter to landing pad A. Angle of depression has to be measured from a horizontal. So you have to think, the pilot's sitting in there, he looks straight ahead, then he looks down. This is the angle of depression. Okay? That is not an angle that is inside of my triangle. It's also not necessarily congruent to this piece right here. It could be, but only if it's 45 degrees, and we don't know what it is. It is, however, congruent to an angle that is inside my triangle. What is it congruent to? Not necessarily 90. What angle would that have to be the same as? Think about your parallel line. Huh? Angle B. If this is horizontal, it's parallel to the ground. You got your transversal, you have alternate interior angles here, so these two are the same measure. So if I find this angle that's inside the triangle, it will give me my angle of depression. Okay, does that make sense? All right, so I need to find theta. Is this going to be law of sines or law of cosines? For law of sines, I have to know at least one angle. I don't know one of the angles, right? So it's going to have to be law of cosines again. When I do my law of cosines, which side length is going to be on the outside? 14, because it has to be the one that corresponds to the angle here. So we get 14 squared equals 8 squared plus 20 squared minus 2 times 8 times 20 times the cosine of theta. Okay, so I'm going to write just one more step. I'm going to move that over there. So I'm going to get 14 squared minus 8 squared minus 20 squared over negative 2 times 8 times 20, and that's equal to the cosine of theta. So go ahead and find theta in your calculator. Let that number look at you, and then we're going to manipulate it a little bit. We're going to find our angle in 3 different forms. Okay? We're going to find it in just the decimal form that we get. We're going to do it in a bearing, and then we're also going to do it in degrees, minutes, seconds. On your assignment, you're not going to have to do all 3, but you will have one where you have to do it in a bearing and one where you have to do it in degrees, minutes, seconds. So we're just going to do all of them on this one to practice. So what the calculator should just straight up give you is 33.123. And so that's just your straight up, here's what my calculator gave me. The next thing that we're going to do is find it in a bearing form. So even though we found this angle, this is the angle we're really, really looking for, right? And so since this is the angle we're really, really looking for, our bearing is going to be south, something east. So I want this piece right here so that I can say it's south and then whatever east. Well, these two together are 90, so I want to subtract this from 90, but not the decimal. No, I don't retype the decimal. Do 90 minus the answer, and we'll get south 56.877 degrees east. Okay, y'all agree with that? And don't clear out your calculator yet, because we're going to have to get the other one back. When you type that into formative, the official correct way, I'm honestly not sure what it is because I tried to find it and it's done different ways all over the place. So just to make it easiest for everybody, make sure there's a space here and then a space between the degree sign and the east. It'll look, otherwise when it's all crammed together, it's hard to read anyway. So just, did we all get this number? Are we good? Okay, so I don't want to have to retype this in every time to get my answer. I want to get this number back. I subtracted this from 90 to get this, so now if I subtract this from 90, I'll get this exact thing back, right? So just do 90 minus the answer again, and you should get this number back. Are we all good on that? Okay, so now I want it in degrees, minutes, seconds. So I know that that's 33 degrees, and so that I can use the exact value that the calculator has, in the calculator, subtract 33, and you should be left with just the decimal part of it. We all good? Okay, so now you're going to take that and multiply it by 60. And when you do that, you get 7 point something, right? So that means that's 7 minutes. Now you subtract 7, you're left with just the decimal part. And you multiply by 60 again. And you should have 22.585 minutes. Okay, and we won't bother writing a sentence for this one, but and like I said, you don't have to do all the versions every time. Just wanted to make sure you knew how to manipulate what you have to get what you need there. Okay? Any questions about those processes? You mean you typed this part in? Okay, we have to do the cosine inverse of this. You have to do it all in one step. Like the cosine inverse of this fraction right here. That otherwise you're not going to get the exact number and then your numbers aren't going to come out right. Okay. All right, anything else? All right. Let's look at this Cincinnati question here. All right, so Cincinnati, Ohio is 540 miles due east of Kansas City. So if it's due east, that means it's to the right of it if we're doing north, south, east, west here. So Kansas City is here. Cincinnati is here. They are 540 miles apart. We've got a bearing from Kansas City to Nashville. So I'm going from Kansas City here, so I need my little north, south, east, west. It is south 64 degrees east. So when I draw that in, this right here is 64 degrees. Okay? Then I have a bearing from Cincinnati. So I need a little north, south, east, west over here. And I'm going south 29 degrees east. So this right here, 29 degrees. And this is Nashville. Okay. So the first thing I want I'm going to find the distance from Kansas City to Nashville. So this is X that I'm looking for. I have 540 is the only piece of the actual triangle that I have information for. I have angle measures, but they're not inside my triangle. That's why it's important that you label them correctly so you know where the angles actually go. How do I find this angle measure right here? It's good. Subtract it from 90, so this would give me 26 degrees. Right? Then same thing over here. I'm going to subtract from 90, so that'll give me 61 degrees. Everybody with me? Okay, so the information that I have in my triangle is angle, side, angle. Is that going to be law of cosines? Law of cosines, you have to know at least 2 side lengths, right? And I don't, so I'm going to have to use law of sines here. So I have this 61 degrees is across from X, and I'm looking for X, so I can take the sine of 61 over X equals, well then 540 is the side that I know. It's across from N. I don't know that angle, but can I find it? Yes. I add these two together, subtract from 180, and I will get 93 degrees. Okay. So then I have the sine of 93 over 540. So X is equal to 540 times the sine of 61 over the sine of 93. So then I can say distance from Kansas City to Nashville is and when you type in your answers, you are going to have to type in the units. So like you would type in the 472.943 miles, make sure there's a space there. I believe the answers only have miles and feet, so use the abbreviation, the MI and the FT. Don't write out the whole word. And make sure you're actually typing these in. So I'd rather you figure out now that something's going weird in the calculator than later. What questions you got? Okay, so we're going to pause here today. I'm going to go ahead and give you the assignment. And then we're going to come back and finish this up today. And on the assignment, we're going to do number 1 together. So I'd rather you skip number 1 right now. But the best thing for you to do on this before you come back tomorrow is try and get all your pictures drawn. Because if you struggle with anything, that's what you're going to struggle with, and we can look at your pictures tomorrow, okay? And then you're going to have time in class to work on this tomorrow as well.